Hi everyone, today I am going to talk about the nucleus of an atom. So before knowing the nucleus of an atom, we should understand how does the atoms looks like. So let's begin. So one of the aspects of physics is that you have to observe the things very carefully, and based on your observations you have to propose your opinion or interpret the particular phenomena in a scientific way. So similar cases happen in the study of atoms too. For example, from Rutherford's famous alpha particle scattering experiment, we came to know that each atom has a positive core, which is known as nucleus. On the other hand, from Bohr's atomic model, we know that electrons revolve around the nucleus in some definite circular path known as the energy levels or orbits. So these E1 and E2 are known as energy levels. And these energy levels are quantized, which means that the electrons in a particular energy levels have definite angular momentum. Therefore, the electrons in the energy levels E have a definite angular momentum, and the electrons, for example, in the energy level E2 has also some definite angular momentum. Now you should understand the size of the nucleus is very small compared to the size of the atom. And the nucleus is made of protons and neutrons. The protons are basically positively charged particles, whereas the neutrons are neutral particles. They doesn't have any charges. These protons and neutrons are called together as nucleons, and these nucleons are bound together inside a small region called nucleus by a very strong force which is known as nuclear force. So this nuclear force is basically a short-range force, and which is opposite to the Coulomb force, which is basically a long-range force. And this nuclear force is solely responsible to bound the positively charged protons inside the nucleus. So as I have mentioned before that electrons revolving in a energy levels have some definite angular momentum, and this angular momentum is equal to the integral multiple of h divided by twice pi, where m is the mass of the electrons, p is the velocity of the electrons, r is the radius of the energy levels, h is the Planck's constant, which is equal to 6.2 into 10 to the minus 34 joule second, and n is simply the integer. Now let us consider light having energy h nu incident on an atom. In that case, the electron in the lower energy level E1 absorbs this energy and jumps to the higher energy level E2. You should know that the energy of the incident light must have to be greater than the energy difference between the energy levels E1 and E2. After reaching the energy levels E2, the electron remains there for 10 to the power minus 8 seconds and then again fall back to its original energy level E1. Similarly, the electrons in the higher energy level can jump to the lower energy level E1 by emitting a light photon having energy h nu. So here h is the Planck's constant and nu is the frequency of the incident light. So the energy difference, that is E2 minus E1, must have to be equal to h nu, the incident energy of the light photon. Now let's talk about how to measure the mass of an atom. Atomic mass or mass of an atom is the sum of the masses of protons, neutrons and electrons. Therefore, if you add all these masses, you are supposed to get the mass of that particular atom. But that does not happen because of binding energy, which we will discuss later. So if you add the total number of electrons, protons and neutrons, you will get a value which is a bit greater than the atomic mass of an atom. Now the problem is that the atoms are so tiny or small that conventional units of masses such as kilogram, gram are not suitable to use at all. For example, the mass of an electron in terms of kg can be measured as 9.1095 into 10 to the minus 31 kg. Similarly, mass of the proton is 1.6726 and 10 to the minus 27 kg, and mass of the neutron is 1.6750 10 to the minus 27 kg. So you can see these masses are too small in terms of conventional units of mass. So a new unit has been used to measure the atomic masses, which is known as the atomic mass unit. So one atomic mass unit is equal to the 1/12 of the mass of carbon atom. Now let's calculate one atomic mass unit, that is U, in terms of kilogram. So we know that 1 mole of carbon-12 is equal to 12 gram, and 1 mole contains 6.62 into 10 to the power 23 numbers of carbon-12 atoms. This is the Avogadro's number. Therefore, mass of one atom will be equal to this much, which is equal to 1.9927 into 10 to the power minus 26 kg, and therefore one atomic mass unit will be equal to 1.6605 into 10 to the power 27 kg. Therefore, if we express the mass of electrons, protons and neutrons in terms of atomic mass unit, so this will become 5.4858 into 10 to the minus 4 unit for mass of the electrons. Similarly, 1.007276 atomic mass unit, or U, for the mass of protons, and 1.008665 U for the mass of the neutrons. Now, one of the greatest discoveries of physics was the discovery of mass-energy equivalence, discovered by Albert Einstein at the beginning of the 19th century. So according to this theory, mass and energy are not independent entities, and they are basically the different aspects of the same thing. So the relationship between mass m and energy E can be expressed as E equal to mc square, where c is the velocity of light, which is equal to 3 into 10 to the power 8 meter per second. Now, as we have calculated that one atomic mass unit is equal to 1.6605 10 to the power minus 27 kg. So if we convert this amount of mass into energy, so this will become 1.6605 10 to the power minus 27 into c square. So this will become equal to 931.502 mega electron volt. 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. So if we express the mass of electron, proton and neutron in terms of energy, so this will become 5.11003 into 10 to the power 5 electron volt. Mass of the proton becomes 9.38280 into 10 to the power 8 electron volt, and mass of the neutron becomes 9.39573 into 10 to the power 8 electron volt. Now you should remember that atoms are identified by two quantities. One is mass number and the other one is the atomic number. The mass number is the total number of nucleons, that is the total number of protons and the neutrons in a certain atom, whereas the atomic number represents the total number of protons present in the atom. So therefore, any atom can be represented by this atomic symbol, where E is the mass number and Z is the atomic number. So these are the representations of some atoms. For example, this is the argon atom. So here the number of protons and electrons, that is atomic number, is equal to 18. The number of nucleons, that is the mass number, is equal to 40, and therefore the total number of neutrons present in this argon atom is equal to A minus Z which is equal to 22. Okay, now let's talk about isotopes, isobars and isotones. So isotopes are basically a kind of atoms which have the same atomic number but different mass numbers. For example, so uranium-235 and uranium-239 are basically the isotopes of uranium atom. So you can see these uranium isotopes have the same atomic number but they have different mass numbers. So isobars are basically a kind of atoms which have different atomic numbers but they have the same mass number. So these are some examples of isobars. So here you can see, so all these atoms have the same mass number but they have different atomic numbers. On the other hand, isotones are basically a kind of atoms which have same neutron numbers but they have different protons or atomic numbers. So these are the examples of isotones. So all these atoms have same neutron numbers which is equal to 20. Now let's talk about the mass defect and the binding energy of an atom. As we have discussed earlier that the total mass of protons, neutrons and electrons always greater than the mass of the atom, which is known as the atomic mass. So in a similar way, the total mass of the nucleus is always less than the sum of the masses of the individual nucleons. That means the mass of the protons and neutrons. Now the deficiency of this mass is known as the mass defect. Now let's Mp is the mass of the proton, Mn is the mass of the neutron, Z is the total number of protons and N is the total number of neutrons, and let Ma is the mass of the nucleus. So from the definitions of the mass defect can be written as the total mass of the protons and neutrons minus the mass of the nucleus. Now since the mass is equivalent to energy, so converting this mass defect into energy by using the famous mass energy equivalence, the EB will be equal to del mc square, which is known as the binding energy of the atom. Now to break the nucleus into Z protons and Z neutrons, so you have to supply an energy equal to this binding energy. So this binding energy basically responsible to hold the neutrons and protons inside the nucleus. Okay, now let's talk about the binding energy per nucleon or the average binding energy of an atom. So binding energy per nucleon or the binding fraction is basically the ratio between the binding energy of the atom to its total number of nucleons. Now if we plot the binding energy per nucleon or the average binding energy to the mass number of the atoms, so we'll get a graph like this. So here we can observe that the binding energy per nucleon or the average binding energy for lighter nuclei, that means the atoms whose mass number is less than 20, it rises very sharply, and for nuclei having mass number greater than 180, the binding energy per nucleon decreases very slowly. So atoms having mass number in between 20 to 180, the changes of binding energy per nucleon is very slow and having an average energy of 8.5 mega electron volt. Now let's try to calculate the binding energy or the binding fraction of an atom. So first we will consider helium atom. So in case of helium atom, the number of protons is 2 and the number of neutrons is 2. Now the binding energy equations can be written as this. So here Mh is the mass of the hydrogen atom, and this is the mass of the neutron, and this is the mass of the helium atom or the atomic mass of helium atom. We will consider here the mass of the hydrogen atom because a hydrogen atom consists one proton and one electron, and therefore instead of proton mass we consider here the mass of the hydrogen atom, because here the electron mass included. We are doing so because where the atomic mass of an atom already includes the mass of the electrons. So the mass of the electron, proton, neutron, and the mass of the hydrogen atom and mass of the helium atom is given here. So after calculations, we will get the binding energy equal to 28.3 mega electron volt. And since the total number of nucleons in case of helium atom is 4, that means 2 plus 2, that means 2 number of protons plus 2 number of neutrons. So binding energy per nucleon will be 28.3 divided by 4 is equal to 7.075 mega electron volt.